get away from nomenclature for a little bit, talking about just some properties of alkenes here. Why is an alkene called an unsaturated hydrocarbon? Well, remember, anytime you've got a hydrocarbon, if it's an alkane, when we first showed you alkanes, we assumed that every carbon was holding as many hydrogens as it possibly could. If you're in the middle of a chain like this, if you're this carbon, you have four arms like every carbon does. Two of those arms are committed because you have to hold hands with your siblings on either side. You've got to hold hands over on your left. You've got to hold hands over on your right. That leaves you with two hands that could be holding hydrogen. And if both of those hands are holding hydrogen, we say that you are saturated. And as long as this chain continues like that, with more and more carbon, and every carbon is holding as many hydrogens as it can while still taking part in the chain, and we'll assume that goes on for a while, then this hydrocarbon would be called saturated. If you make a double bond, you come along and say, all right, you two carbons, I want you to hold hands twice. And each of them says, well, my hands are full right now. The only way that these two can do this, they can't let go of each other. They're trying to form a double bond, not zero bonds. If they're going to hold hands again, this left carbon has to let go of one of its hydrogens, and the right carbon has to let go of one of its hydrogens, and now this arm and that arm could link up, and now those carbons can double bond. It's like someone wants to shake hands, but you're holding a grocery bag and so are they. If you each drop your groceries, now you can shake hands because you've each freed up a hand to do it with. These carbons can double bond because they've each freed up an electron to do it with. But in the process, each of them has orphaned one of these hydrogen atoms. These will probably combine into a hydrogen molecule. But this means you're no longer saturated. These two atoms are no longer holding as much hydrogen as they could. In fact, they had to give up some hydrogen to get here. So anytime you see an alkene with a double bond, or later an alkyne with a triple bond, that automatically means they've given up some hydrogen to do that, and they are not saturated. So alkanes are saturated, alkenes are not, alkynes are not. What is the smallest, simplest alkene? Draw its structural diagram. When you hear small and simple, the obvious place to start is, well, let's just do one carbon and see if we can make it with that. The trouble is, an alkene is defined as a hydrocarbon with a double carbon-carbon bond in it. And you can't do a carbon-carbon bond with only one carbon. If you're going to shake hands with something else, or hold hands twice with something else, there has to be you and the other person present. So the simplest alkene that can exist has two carbons inside. And what do we call this? Two carbons is ethane if it's single bonded, and ethene if it's double bonded. Ethene. And to finish this structure, each of these carbons has four arms. This one's using two arms to hold on to its friend, so it can take two hydrogens. You can draw these up down if you want to, but it's somewhat closer to the truth because the electrons repel each other. They will angle out like this. This hydrogen wants to get as far away as possible from all the other electrons in here. Same with this. Each of these bonds will angle out as far away as it can. In other words, the shape around each of these carbons is trigonal planar. Roughly 120-degree angles here. If you're going quick and you do this, not super wrong, but misleading and not as close to the truth as this is. So this is okay, and this one is definitely preferable. That's the simplest alkene. You can have a single carbon alkane because those don't need to have any double or triple bonds between carbons. There you can just have a single carbon and then put hydrogen around it. But for alkenes and alkynes, you need a minimum of 2 carbons so that you can make those double and triple bonds. And finally, name the following structure. What is this? Its primary has 3 carbons in it, so we can write prop. If it was all single bonds, I'd be writing propane here, but it has a double bond, so it's propene. And I left a space here so we can talk about where the double bond is. Now, what I do next here might annoy you, but bear with me for a second. I know it's wrong, and we'll talk about it. This double bond is between the first and second carbons if I number this from the left. If I number from the right, it would be between 2 and 3, so certainly I'm going to pick to number it this way. And so it seems like maybe I should call this prop1ene. But we don't. Why not? We don't because even if we moved the double bond to the other side, we would still call that prop1ene. If I took this double and moved it over here, then whoever was naming this would immediately go, well, I'm changing my numbering now. And they would still call it prop1ene. This is a case where when you have just one double bond, it's automatically going to be in position 1. And so chemists save themselves a little bit of trouble by not giving that number. And shown a molecule like this, they would simply call this propene. And when you see that and think, oh, the number's missing, you think they must not have had a choice if they left that number out. So if you said prop1ene, not exactly wrong, but it's definitely cleaner and preferred to just call this propene, because no matter where that double bond is, we will set our numbering so that it's carbon number 1. Since there's no choice about the number, don't even bother telling people the number. Good?